Hi there once again, and welcome to another Expresso mechanic tutorial. And in this one we're going to be rigging this weird and wonderful machine that you see before you, which is based around a Trammel of Archimedes, and that's the device at the rear of the machine which is driving the whole thing. It's pure Expresso, and we're going to be employing the talents of the range mapper node, and we'll also be using the ray collision node to help us out as well. The scene file for this particular tutorial is available, and I've given you a link within the show notes, so be sure to download a copy of that and get it on your computer before making a start. But anyway, that's what we're going to be about in this tutorial, so without further ado, let's see if we can make this happen. Within our Trammel of Archimedes model here, we've got a number of different objects in there, some of which we will need to work with and others we can completely ignore. The inanimates, we don't need to worry about any of those. They're just the uprights and nuts and bolts, things like that, that we don't really need to worry about because they're not animated. The drive shaft we certainly do, and the driven, the springs, these are targets for our cams and cam followers. So we've got all of those items in, and as I say, the animated objects are here, and they're the ones we're going to be most interested in. Let's start by adding an Expresso tag, and we'll make a start and think about where we're going first. The driver for this is going to be the drive shaft, which is attached to the Trammel of Archimedes. So we can think about making this work first. Now, the way I'm going to do this is to bring in a time node. As per usual, remove the time port and add a frame port. Just get rid of that and add that one. And then the next thing we're going to need will be our first range mapper. And as I say, we are going to be using a number of these, but we'll bring our first one in. Just place it here, connect the frame output to the input, and then we can think about setting the range mapper up. Now, I'm going to check modulo because I will be using this, because what I want this thing to do is oscillate, and I want it to keep on repeating. So I'm going to use the modulo. Our input lower will be 0, and our input upper 300. So I'm going to make this thing oscillate over 10 seconds, because obviously 300 frames, 30 frames per second, it equates to 10 seconds. We'll give ourselves some more frames in the timeline, just sort that out. I'll give myself 1,000, I think, just as a round figure. And then in the output lower and upper here, we need to change the range to degree, because that's what we're going to be interested in. And we need 1660 degrees. And that will be because we're going to be turning this shaft, but we need a ratio because this wheel here, which is driven by the Trammel of Archimedes, actually rotates twice for every one revolution of the Trammel of Archimedes. So this is the figure that we're going to actually need here. So 1660, that works out and it makes everything synchronize. The final thing that we need to do is place a bell curve in the spline, because as I say, we want the thing to oscillate. So let's start adding some points. We just need 3. And if we twirl this down, we can see that we want our X to be 0.5 and 1 for our Y for this center point here, and our tangents minus 0.25. And then we've got 0.25 here, and we need to set that to 0 and 0. This one needs to be at 1 and 0, and our left tangent minus 0.25. And that gives us the perfect bell curve. Fantastic. Let's bring in the drive shaft. And we can think about setting this up. It will be rotation B that we're interested in. So let's get that in at the input stage. So transform rotation, rotation B. We'll connect this up, and then we can run our timeline and see what happens. So away it goes, and we can see that it slows down and then starts to go in the opposite direction. And because we've put the modulo within the range mapper, it will keep on doing this as long as the timeline is running. So that's great. That's the first part of this worked out, and it's doing exactly what it needs to do. Moving on from here, we're going to be interested in driving this wheel and in turn this worm gear. So that's going to be our next port of call. We'll bring in another Expresso tag, place this one second in the queue. So we've got nothing in there at the moment, and we need to bring in our drive shaft. So we'll bring that in. We know that rotation B is what we've been working with, so at the input stage, or rather the output stage, I beg your pardon, let's just put rotation B there. And then we can think about what we're going to do with this. Well, we'll bring in another range mapper. Place it here and connect the output from the drive shaft into the input. And then we can think about setting this particular range mapper up. And this is going to be driving driven. So we'll bring this in, place it here, and at the input stage, we'll give this rotation B, because once again, that's what we're interested in. And that's ready to go. Let's think about this range mapper. The input and output ranges both need to be degrees on this occasion. And we don't need the modulo because that's dealt with by the previous expression, so we don't need to worry about that. At the input stage, we can say 0 to 360. That's perfectly good. But we just need to change the output upper to 720. Because as I said, for every one revolution of the Trammel of Archimedes, this wheel rotates twice. So where do we go from here? For a start, we can connect this to driven, and we should now be able to simply run the timeline and see this work, and straight away we do. So those two are synchronized, and we can see that the worm gear is turning, all behaving correctly. The next thing that we can do is actually move our cams. We can get those actually, these two here, these two triangular shaped objects are our cams, and we can get those moving. We won't get the cam followers moving just yet. We need another expression for that, but we'll get these two moving. In order to do that, we need a second range mapper. So we'll bring one in, calculate range mapper. We'll just place this one a little bit lower. Just move these up. Just place this here. Connect the output from our drive shaft to the input. And then we're ready to set this one up. The input range needs to be degrees, and our input lower and upper, they're almost right. We just need to change the upper to -360. Because if we don't, our cams will move in the wrong direction. So we make sure that we do that. So -360 in there, and then the output, lower and upper. Well, if we just switch to a right-hand view, so F3, and I just hit H, and we move a little bit closer. Basically, for every revolution of the worm gear, the cam follower needs to move this distance, and that equates to 3 units. So we can put 3 in there. So that's our range mapper set up. We don't need to worry about the spline or anything like that. We're okay there. And then we can bring in our followers. So, or rather our cams, I beg your pardon, with our left and right cams, they're all we need to bring in. So we'll bring our left cam into here, our right cam into here. If we select them and we just move this out of the way and select our axis here, we can see that we're going to be interested in the Z position. So we can say transform position, position Z in both of those, and we can plumb the output of our range mapper into both of those inputs. Let's just shut this down and let's see if it works. And we can see that it does. Our cams are following the worm gear and they're perfectly synchronized with it. If we go into our top view, hit H and just move a little bit closer, we can see that they're here. There's 2 pins here and they're following that perfectly. So yeah, everything is synchronized and it's all looking really good so far. Moving on from here, we will need to get our cam followers actually following our cams. And that's going to be the next port of call. And this in turn will make it's an E and an M actually. They're the 2 letters for Expresso Mechanic. I mean, put your initials in there if you don't want to use E and M. But that's what I've got in there. That will make the letters raise and lower. Okay, that's our next port of call. We'll bring in another Expresso tag. So programming tags Expresso. Place this one 3rd in the queue. And then we're ready to think about where we're going from here. For a start, we can bring in our left cam. So we're interested in this here. At the output stage, we'll give it an object port. And then we can bring in T3 and T4 because they actually pertain to this particular cam follower. And they're the ones that we're interested in on this occasion. Now T4 you can see is high up in the cam follower here, and T3 is down at the bottom. And if we just zoom in and get a little bit closer, we can see what's going on there. Yeah, we can see that it's just below the level of this flat part of the cam, and that's where it needs to be in order to make the cam follower remain in contact with the cam at all times. So that's going to work perfectly well. So we'll bring the 2 of those in. It doesn't really matter which order they go in, but we'll do them in numeric order. Put T3 above T4 just for the sake of clarity. And at the input stage, we'll give them global position ports. So we've got those 2 and they're ready to go. We can then bring in the all-important ray collision node and connect the object ports together, and these 2 can connect accordingly to the ray points. Now the ray collision node, at the moment we've got text only checked and global coordinates. We don't need either of them, so make sure you turn both of those off. And then we also need hit position at the output stage. Now the hit position is producing a vector, but we're interested in working with a real value. So let's get an adapter. And we need vector to reals, and we can plumb the output of the hit position into the input. We're only interested if we select our left follower. That's the one we're going to be interested in. We know that it's got to move along its y-axis. So the Y is what we're interested in, and we can then twirl this open, bring in Aleph, just drop it here, and then in our coordinates, transform position, position Y, and we can connect that accordingly. All things being fair, this should now work. So let's just run the timeline. And we can see that it is, and the M rises up out of its box and then goes back down again. So that's perfect. That's working fine. To get the right-hand cam follower behaving as it should, all we need to do is copy this. So we'll command drag to copy it all. And then we just need to change the various objects. We'll bring our right cam in. In fact, what I'll do, so that we don't get any mess, I'll just disable this expression for now. And then we'll set it up and we'll get it going again. So let's just bring the right cam in and drop it in there. So we've got that there. We can use T1 and T2 for our targets. And then finally, if we just close that one up, we've got our right follower. We can just bring RF in and drop it here. And now everything should work fine. Let's just check that back on. We can close this down and let's just run the timeline. And there we go. Our cam followers are working perfectly. Fantastic. So the final step for us then is to simply get the springs to behave in the correct way. We'll bring in our final Expresso tag, and then we can start. We need to bring in Alain again, and we need its position Y at the output stage. We can then bring in another range mapper. I told you we'd be using quite a few. Place this here and connect the output from Alain into the input. In our range mapper on this occasion, we need a number of different figures. So we can start with 0.5. Now let's just take a look at where we are here. If we take our left cam, we can see, let's have a look, see where we are. It's our cam follower that we're interested in. Alain starts at 0.5, and if we click on RF, we can see that it's at 10.8. So these are going to be our input ranges. So 0.5 and 10.8. Our output ranges are going to pertain to the heights of our springs. Now, if we just open up our M spring and click on the helix, M helix is what we're interested in. Now, we can see that it's upside down. So it's grouped into a null, which is at the base of the helix, giving it its 0 height at this point. So we can see what we've got here. Its height starts at 17.9, so that will be our output lower, so 17.9. And if we just open our E spring and click on its helix, we can see that its height is 7.6, and that's when it's fully compressed. So that's our output upper, 7.6. They're the numbers that we need to place into our range mapper to get this to work. And if we bring in our M helix and connect this to the height, come down to our object properties, height, this should now work. Let's just play the timeline, and we can see that that spring is behaving as it should. So all we need to do then is bring in RF, give that position Y at the output stage, copy this range mapper because the same ranges apply to both helixes, and then all we need to do is bring in the helix from our E spring, so E helix, just bring that in and plumb this into the height. Close up our expression, return our timeline to 0 and play, and the whole thing should now work. And indeed it does. And that's looking great. Fabulous. And that is how you go about rigging a Trammel of Archimedes contraption. And that just about brings us to the end of this tutorial. We've got our machine rigged and it's looking very, very pleasing on the eye. And I've shown you everything that I wanted to show you in this one. And as always, I really hope that this has inspired you and has given you some ideas for things that you may be able to incorporate in your own projects. And if you have enjoyed the video, please give it a like, and if you haven't already, please subscribe to the channel, leave a comment, and of course ring the bell. And wherever you happen to be on social media, please do share this video, because I really need the views and the viewing hours, and all this good stuff really does help keep the channel moving in the right direction. But anyway, that just about brings the curtain down on this one. So I'll see you very soon on the next tutorial.